All right, class. So we're gonna do the next one, which is uh, data frames, right? So you're gonna click download, right, and then you're gonna upload it into your call app. That way you can follow along. Okay. And so we're gonna start with data frames. So data frames are the workforce of Pandas and are directly inspired by the R programming language. We can think of data frames as a bunch of series objects put together to share the same index. So the way I want to think about it, we talked about a series, right? A series is just one single column that has an index column. So that's the only difference between an array and a series. An array does not have an index column. Okay, there's a way to access any element in your array, but it doesn't have a way to an index location, right? An index column. And so instead, a series does have one single column. It's just one column with a column index label. Okay, so that's the difference, right? So what is a data frame? A data frame is a combination of series put together with the same column label. Okay, so a data frame is a combination of series, like you have a couple of series, right? So you're gonna have multiple columns, right? Each one is gonna be like a series. They share the same common column label index. Okay, so that's practically what it is. So the first thing that we want to do is import the pandas as PD. Again, it's just a short to call it short instead of using pandas. We're going to call it PD. Numpy as MP. Again, this is not a rule, but it's common practice to do this. Now we're going to run this one, and then we're going to run the next one, and we're going to do from numpy random, we're going to import rand. And remember, we talked about rand in the numpy section. And what it does is, so what we're doing here is we're telling the computer, from the numpy library, look at the random and import this random and function or method, right? So what it does, it gives you a random number between -1 and 1, and with a standard deviation of 1 and a mean value of 0. So just remember that. Okay. We're going to use mp.random.seed, and we're going to use 101. So what it does, so random supposedly gives you a random number. Nothing is random in the computer science, right? So far, because it follows an algorithm, right? But what we're trying to do here is, when we use this word seed, what we're trying to do is control the randomness. The reason is so that we both can get, you and I, whoever's following my work, or whoever, or sometimes when you're doing a project and you want people to get the same result as you, and you know that you use a random numbers, right? Then they get the same result by using the same seed. So you can use this. You still have a random data, but you're kind of fixing the randomness of that element so that other people can get the same result as you if they use your same project, if they're trying to verify your project. Okay, so that's practically just to control the randomness so that people can get the same result in your randomness. I'm still going to get a random number, but it's going to be fixed by this 101, by this seed 101. Okay. And then I'm gonna do here is I'm gonna create my data frame. So usually we use df to represent a data frame, short for data frame. So I'm gonna create this object, and I'm gonna use a PD data frame. So I'm using pandas data frame. So this is the constructor that is going to allow me to create a data frame. Okay, and I'm going to use a rand and from 5 comma 4. So I'm going to create a random matrix from 5 and 4 size 5 and 4. Okay, and my index will be my index labeled will be A, comma, or A, B, C, D, and E. And what I'm going to do, I mean, I could have created a list, but sometimes it's easier just to write a string and do a split. Remember, a split turns a string into a list. So I'm passing in a list, technically. That's my index. And I can do the same thing with my columns. So I can specify what my columns will be. Remember, a data frame is a bunch of series combined together. And so I'm going to pass in W, X, Y, Z, and split. And there you go, right? So I'm going to generate random numbers, and then I'm going to be able to have this A, B, C, D as my index labels. And then my columns will be labeled by W, X, Y, and Z, right? I have to run it. And then df. And you can see we get the same values. If I remove this, if I remove this part right here, then I'm gonna get different numbers. So if I run this, and I run this again, and I run this again, you can see that I'm getting different numbers now. But notice that if I put this, I'm getting these random numbers. If I put it back, I'm gonna get the same random numbers now, again. And this is just, again, if you want people to be able to follow the same data that you did and to get the same results, then you tell them, you use this line, seed 101, or seed, you can change it to 42 if I want to, or any other number you want. It doesn't have to be 101, but this is going to be fixed to this seed 101. Okay. And then now I can actually access any value that I want on my data frame. So I can do def, sorry. I keep saying def, and then W. So that's going to allow me to access any value on my column, W, with my label column, my index column as well. And you can see that I'm grabbing the first column. And I can grab multiple columns if I want to by doing a list, passing in a list. So I can do df, and I can pass in a list of the columns that I want to be able to access. And so now I'm accessing W and Z column. And I can access and another way to access a column would be just to do df.w, but this is not recommended. Okay, it's not you don't quite get the structure of the data correctly, right? So not recommended. And if you want to see what type of data you have, what we can do is we can say type.dfw. So what we're doing is we're checking what kind of data this whole thing is. And every time you want to check the data, you can just type on anything that you want. And you can see this is a Pandas series, right? So this is a series. One of them is just a series. And so if we were to do type def, now you can see that this is a type data frame. right? So one column, when you extract one column from the data frame, you're talking about a series, but the whole thing is a data frame. You could have a data frame with just one single column, don't get me wrong, right? But if you're extracting one of the columns, then you're talking about a series. Okay, so this is perfect to be able to know what kind of data type you're working with. It's always good to know what the data type you're working with. So trust me, you should always figure out what data type you are working with, because depending on the data type, it will depend on the tool or method function, or sorry, method or attribute that you're going to use for your, not function, but method that you're going to use for your tool, for whatever you're trying to do. So in this case, we're going to be adding two different columns and make a new column. So we're going to be able to create this new column and add it into a data frame. So if I ever want to make a new column, all I have to do is add a different name inside my DEF and inside the brackets, and that's going to automatically make it into a new, it's going to add a new column. So I'm going to do this, and then I'm going to put DEF, and you're going to be able to see that I'm going to add a new column. Now I could, if I want to, notice that if I put lowercase x, that would have been a different column, and I can say def, and I can put capital X, and that is going to add a new column into my data frame. But I don't want to do it. I want to mess with my data. And so we can also drop, we can make changes to our data frame by doing the method call drop. And so what we can do is we can say specify which column we want to remove. And so I'm saying I'm going to remove the new. And we need to use the axis to refer to the columns. So equals 1. So if I want to refer to the columns, I have to use the axis equal to 1. Otherwise, it would drop a row. So for example, let's see. Let me show you here. So now you can see that it dropped that it dropped the column. Okay, I'm not showing you when we can drop a row, but you can see that it dropped the new column. And then we can do and then you can see here, we can just print it up just to see what we have. And notice that it's still there. But wait a minute, I thought we dropped it, right? But remember, a lot of these tools are set up so that just in case you make a mistake, you don't lose your data. So you have to actually, if you want to make a change, you have to really manually make something different. You have to manually specify that you want to make a change. And this is just to protect yourself. So right now, even though I dropped the new column, it's still there. The column is still there. I didn't delete it. If I want to permanently delete it, if I want to remove it permanently, I have to do an extra work. And that is just to make sure that you don't make a mistake. So it's a safeguard for you so that you don't accidentally remove a column that you don't want to remove. So if you want to remove something, you have to say in place true. So you have to manually say if you want to remove something or not. Okay, so in this case, as you can see now, if I do def, now my new column is gone. So what this is saying in place is saying that my result, my copy, right, should be replacing my def. Okay, so we could have done it in a different way, but this is the clean way of doing it. Okay, I could have just resave it back to itself. So I could have done def equal def dot drop new axis equals 1. And that would have done the same thing. I don't have to do in place true. I could have done that, but we already have an argument that allows us to be able to make changes to it. So why not use it? Well, this is gonna complain because it doesn't exist anymore. So notice that if I try to do it again, it's not going to it doesn't, this new column does not exist anymore. So notice if I run this, the new column does not exist. So if I want to put it back, I would have to go back in here. So if I want the new column to be back again, I have to go all the way to the top to make sure that it's there. And then you can see now that it's there, and then now I can drop it. So notice that you might be able to get those mistakes, right? Because right now my DEF does not have new anymore. So if I run this again, this line again, I'm gonna get an error, okay? Because the new column does not exist anymore. Just remember that. That can happen a lot to you guys. Just remember that you already remove it, so it doesn't exist. If I want to drop a row, I can specify which row I want to drop. So let's say I want to drop the E row. I'm going to use axis equal to 0. So axis equal to 1 refers to the columns. Axis equal to 0 refers to the rows. So if I run this, now I don't have the E row. And so now if I want to select a specific row, I can actually specify by using what we call a lock. So that will be a location, referring to the location. And right now my labels are A, B, C, and D, right? So right now my location is specified by the letter A, B, C, and D, my labels. So if I want to access my row, my values on my row, I have to specify that I want to locate the location of my row A. I want to have all those values. So if I do this, I'm going to be able to access every single element on my row. Now there's another way of doing it without the label A, and that's using what we call an E-lock. So that would be E-lock, so referring to the index, and then I can say instead of A, I can specify index 0, and that should give me, well, let's do C. So that's 0, 1, 2. So if I want to do C, I have to do index 2. And that's going to give me the values at index C. All those values. So you can see name C. So I was able to access that value. So lock is for the actual name of your label. E-lock is for the index number, the location number, the index location number. So this is for labels, and this is for the index number. All right, and then let's have, now we can select subsets of the of my data. So I can say df lock location, and I can save b comma y. So what I'm doing here is I'm selecting row B, column Y. So I'm selecting a specific element. I could have done it, I think we can do it a different way. So let me just run this one right now. So you can see I'm looking at the row B, column Y. I think we could also do, I think we could do that one as well. And yes, so this is another way of doing it, right? This is your rows, and this is your columns. So you can either do it with brackets or with just a comma. Okay, just like the way we did it for arrays. And so that's if we want to grab one specific element. We can do multiple elements by doing a list. of A, comma, B. So this means that I'm trying to grab the row A and row B and columns W and Y. So this is to access row A, row B, column W, column Y. And so that's to access different tools, right? I could have done also the uh, instead of columns, I could have done a colon. So instead of columns, I could do a colon that could do slicing. So like a subsection. And then we can do conditional statements to data frames as we did for the arrays and series. So I'm just double checking that my DEF is that. And I can graph all the DEF, all the values that are greater than 0. And this is going to display a truth table with all the values that are greater than 0. As you can see, this is greater than 0, greater than 0, greater than 0, greater than 0, not greater than 0, not greater than 0, greater than 0, not greater than 0. And so it's true, false, false, true, right? And we can also just actually have a data frame that satisfies those conditions. So I can do df greater than 0, and that's just going to give me the values that are just greater than 0, and everything else is just going to be none. And then we can do a more advanced to just one specific the row. So we can do df w. So we're looking at the w column, and I want this to be greater than 0. So what we're doing here, so you notice that it removed any column, any row that doesn't have where w values is not greater than 0. So notice that this is the row that has in the w a number less than 0. So we're gonna remove this row. So that's what this is gonna do. It's just gonna display a data frame where the C is not there anymore. And we can do the same thing and just specifically see one single column if we want to. Oops. Let's say we want to look at the Y. And you can see that we're just grabbing the specific column values of the Y. We can do it specifically for more than just one. So we could do 2 values. Oops, sorry, I jumped 1. Let's put Y and X. And so oh, sorry. I have to put a list here. I have to put a list inside my bracket. Oh, I'm missing here. And there you go. So I have to put a list of the the columns that I want to display. So not just a bracket of the elements. That's incorrect. I want to display this column and this column, so it has to be a list. I have to submit a list. And then what we can do is also we can do a comparison. So we can do a comparison here. So I want to check all the elements. I want the rows that are where my W is greater than 0 and my rows for my Y are greater than 1. So we're looking for all the rows where, so let's look at our values here. We're looking for all the rows where my W's value will be greater than 0. So not this one. We don't need this one. We're not going to be able to have this one. And all my Y's are greater than 1. So this is less than 1, less than 1, less than 1, less than 1. And this is the only one greater than 1. So we're not going to have this one. We're not going to have this one. All this we're not going to have because my W is less than 1. Sorry, my Y is less than 1. And the only one that satisfies the fact that W is greater than 0 and my Y is greater than 1 is E. That's why we're going to get just the E here. All right, so let's do more indexing. So def just to see what we have. And then what we're going to do here is we're going to reset our index. And so right now our index is A, B, C, D, E, right? But we want to be able to, you see A, B, C, D, E. We can reset them to be represented by integer values. And so we get those, right? So now we can see that my index values are 0, 1, 2, 3, and 4. We still have this column with the index name. But now we have a location of index 0, 1, 2, 3, and 4. And now what we can do here is we can split here. Let's create a list of California, New York, Wyoming, I think, Oregon, and Colorado, and we're gonna make it into a list by using the split. And we're gonna make a column of states by using my new win. And then we're gonna go, oops, new states, oops, sorry, equal. And then we're gonna add it into, we're gonna display our DEF, our data frame. So you can see now we have this column of states. Then we can change this set states to be our index label if I want to, right? So what we can do is we can define our data frame to be set index to the states. So here what we're doing is we're changing the last column, right, the states column, to be now represent our index label. And there you go, which is very useful. Sometimes you want to change your column index, and this is a very good way of doing it. Now, if I do def again, I didn't make any changes permanently. Again, this is to protect yourself. So if you want to keep something permanent, you have to do set index states, and then we need to do in place equals true. So this is to replace the data frame that we have with the new outcome, the new output. So now if I do def, this is permanently saved. Just again, it's to protect ourselves from making a mistake. Okay. Remember, some of the data is sometimes we don't want to alter it, we don't want to lose it, because it is the data that we're going to do for the rest, for many different I don't know, problems, or you're gonna try different solutions, different paths to find the solution. So you don't want to mess with the information. Let's create another data structures. We're gonna call it outside, and this is going to be G1, G2, oops, G3, G4, G5, oops, actually G1, hold on, actually I want to have G1 here, and G2. Sorry, I was trying to do something different. G2. Inside, we're gonna have 1, 2, 3, 1, 2, 3, and then we're gonna have higher index equal to the list zip outside inside. So what zip does, it maps the items from this list to the items on this list. So it's going to be G1 with 1, G1 with 2, G1 with 3, G2 with 1, G2 with 2, and G2 with 3. So it maps them together. So that's what zip does. And so we're creating a list of tuples practically. Higher index, and we're going to turn it into a data frame by using a multiplex from tuples, and we're going to use this higher index. So what we're doing is we're turning this higher index into a multi-layer data frame. And so if we run this, sorry, where did I go wrong? Multiplex, pandas, multiplex. Multi-index, sorry, multi-index, not multiplex. Multi-index. That's my bad. And then we can do the higher. We can see what we have now. And we can see that we have this data, this data frame, right, with G1, 1, G1, 2. So you can see this. Did I do tuples? Yes. So you can see the mapping between G1 and 1, G1 and 2, G1 and 3, G2 and 1, and so on and so on. Okay. All right. So what we're going to do now is we're going to show it in a different way, but I guess it didn't do it. Anyways, so let's change this data frame, this modified, and so we're gonna turn it into a data frame, and we're gonna use a random dot rand. This is to generate values of a size row 6, column 2. Index is going to be our higher index, and our columns will be A, and B. So what we have done is we have generated this index, multi-layer index for our data frame. We could do the same thing for our columns, but you can see here that I'm still creating this random data from this random rand and with dimensions 6 and 2. And I'm using, the only thing different is I'm using this index, higher index, as my index label. And my columns still have been the same. I still have to submit a list. And we can see our def, and so that way you can see what the outcome is, right? You can see multiple columns, sorry, multiple rows, G1, and G1 has 1, 2, and 3, G2 has 1, 2, and 3. So you can see that we have a multiple layer row. Okay. And now what we can do here is I can access any column that I want by using my location and use, for example, let's say I want to access my G1. All I have to do is use the bracket location, right? This is my location of my column, my row, and I'm saying I want to access G1. So it's gonna give me that subsection of the, I don't know, we want to call it frame, data frame from G1. We can access a specific element if we want to of my G1. So if I can say, if I can specify a row, a specific row by doing a second dot log, and this is going to specify the row that I want to access. If I want to access that row, I can put 1 there, and that's going to give me my -49 and the negative 0.75. If I want to access names, I can do df.index.names. It tells me it doesn't have so far any names for my index, and I can assign them group names if I want to by doing df equals group num, and now we can see that my columns for my rows index have a name now. Okay, and I can access, another way of accessing a specific subsection of my data frame is to use what we call the XS. So I can do .xf, xs